Reinforcing again the concept of electric field. Electric field is the force per unit charge, the number of newtons per coulomb, on a hypothetical test charge located at position A. That is, the electric field at position A is the vector force per 1 coulomb test charge at A. So we calculate the force on a 1 coulomb test charge, and then we divide that force by 1 coulomb, and we get the electric field. These numbers should be familiar to you from the preceding analysis. The force at this point is easily calculated from Coulomb's law to be 68,000 newtons, provided that we bring a 1 coulomb charge into this point. That means that the force per coulomb is 68,000 newtons, so that the electric field is the force divided by the charge, the force divided by 1 coulomb, or 68,000 newtons per coulomb. The angle is the inverse tangent of 0.4 over 0.7. If we just look at the triangle, we can see how that's going to work out, and that's 29.7 degrees. Okay. If we put a 3 microcoulomb charge at A, then what's the force going to be? Well, it's going to be 3 times 10 to the negative 6 coulombs, which is our 3 microcoulombs, multiplied by the number of newtons per coulomb, which we calculated to be 68,000. So that we end up with a force, well, when we multiply these numbers, we get 0.2 coulombs times newtons per coulomb, certainly going to give us newtons. And for some reason we're saying that that force is at, oh, that looked like 227, forgive me, can't read my own writing. That's 29.7, might be, is equally hard for you to read that, but 29.7 degrees. Now if we're given the charge Q and the electric field E, what do we do? Same thing we did here. We had a charge Q and an electric field, 68,000 newtons per coulomb. We multiply the coulombs, the charge, by the newtons per coulomb, the field, in order to get the force. And if we have the vector form of the electric field, we're going to get the vector form of the force. If we brought a charge of negative 6 microcoulombs to the same point, then the force would be calculated by multiplying the negative 6 microcoulombs by the 68,000 newtons per coulomb. We would get something very close to negative 0.4 newtons, actually about negative 0.41 newtons. If in the angle would be 27 degrees for the negative 0.4 newtons. The 27 degrees on a negative force is really 29.7 degrees for a negative force is 29.7 degrees plus 180. In other words, equal and opposite to that force. And it looks like I wrote down something else carelessly here. I was writing down 4 newtons. Newton starts with N, so does 9, so obviously I wrote down a 9 here, but that's really 4 newtons at the 29.7 plus 180 degrees, or the 209.7 degrees.